All right, buckle up, everybody, because today we are taking a deep dive into some pretty awesome stuff from BepiColombo.
Yeah, really exciting stuff.
You know that mission, the one headed to orbit Mercury?
Oh, yeah. I've been following this one closely.
Well, this is really cool because it's not just like a straight shot to Mercury.
No, it's not.
It's making these flybys, getting closer and closer each time.
Yeah, it's using those flybys and Mercury's gravity to adjust its course.
Yeah.
You know, like a little nudge each time.
Like Mercury's giving it a little cosmic high five as it goes by.
Yeah, gravity assist, we call it.
Oh, fancy.
Yeah, that's the technical term.
I like cosmic high five better, but
Yeah.
but that's incredible. So we're getting these sneak peeks as it goes, right?
Exactly.
I mean, most probes, they just fly straight to their target.
Right, straight there.
But with these flybys, it's like we're getting a front row seat.
It's really unfolding in real time.
Yeah. And with each flyby, we learn more about Mercury.
Yeah, and we're learning that it's a pretty extreme place, you know.
Oh, tell me about it.
You've got scorching temperatures during the day, then plummets to like frigid cold at night.
Oh, wow. Like, what kind of temperatures are we even talking?
You're looking at 472 degrees Celsius during the day.
472 Celsius. That's got to be like, I don't even know, hundreds of degrees Fahrenheit.
Oh,
Wow.
yeah, definitely.
That's wild.
And then at night, it's negative 200 Celsius.
What?
Yeah.
So it's like a furnace and then a freezer all in one?
Pretty much.
And on top of that, it's got the surface super cratered.
Yeah, almost like our moon.
Oh, wow. So kind of like desolate, right?
Well, I mean, it's harsh,
Yeah.
but I wouldn't say desolate. Mercury's complex.
Okay.
Really complex, fascinating planet.
Right.
And we've only had two other spacecraft visit, Mercury, Mariner 10, and Messenger.
Oh, yeah. Okay.
So BepiColombo, this is huge.
Yeah.
You know, it could really change our whole understanding.
It's like we're finally getting a good look.
Yeah, for sure.
I remember learning about Mercury in school, and it always seems so mysterious.
Well, it's hard to observe from Earth.
Yeah.
I mean, it's always so close to the sun. It's like trying to see a firefly next to a spotlight.
Oh, yeah. Good analogy.
Yeah, it's tough.
So that's why BepiColombo is so important.
Oh, absolutely.
We're getting this close-up view we rarely ever get.
Yeah, and what's really cool, too, is this is a joint mission.
Yeah, I was going to say that there are like two different agencies involved, right?
It's the European Space Agency, that's ESA,
ESA. Uh-huh.
and the Japan Aerospace Exploration Agency.
The JX.
The JXA,
They're
exactly.
like a global team effort.
Yeah, real teamwork.
And they sent two orbiters, right?
That's right.
One from each agency.
Yeah, so you've got the Mercury Planetary Orbiter, that's from ESA.
Yeah.
And then you've got the Mercury Magnetospheric Orbiter from JXA.
Wow, so they're really tag teaming this thing.
Yeah, working together to study every aspect of Mercury.
I love it. All right, so this latest flyby, this was back on January 9th.
Uh-huh.
That gave us some incredible images.
The images are spectacular.
All right, let's dive into these. Image number 1.
Okay, let's see.
Whoa, it's so cratered.
Yeah, it's heavily cratered.
And are those craters at the North Pole?
Yeah, you're seeing the northern polar region there.
Huh.
And those craters, those are Prokofiev, Kandinsky,
Okay.
Tolkien, Gordimer. Those are in permanent shadow.
Wait, hold on. Permanent shadow.
Yep, permanent shadow.
But Mercury is the closest planet to the sun.
Right.
How can there be permanent shadow?
Well, because of the tilt of Mercury's axis and the way those craters are positioned,
Oh, okay.
they never receive direct sunlight.
So these craters, they're like some of the coldest places in the whole solar system.
You got it.
Wow. And not just cold, right? They also didn't they find like water ice there?
Yeah, evidence of water ice.
The water ice on Mercury, I thought it was like a burning inferno.
It's a planet of extremes, that's for sure.
This is what I love about space, always throwing curveballs.
Yeah, always keeps us guessing.
All right, image number 2. What are we looking at here?
All right, so this image shows a region called Borealis Planitia.
Borealis Planitia.
Yeah, it's this vast plain, and it was formed by volcanic eruptions billions of years ago.
Really?
Yeah, so all those smooth areas you're seeing, imagine massive, massive lava flows just spreading out and solidifying.
Whoa. So early Mercury was way more volcanically active than it is today.
Much more active, yeah.
I wonder what caused all those eruptions.
That's one of the big questions, right? What triggered them? How long did they last?
Yeah.
And look closely, you can actually see craters that got partly filled with lava.
Oh, I see. Like right there.
Yeah, like Hellery and Lismore. Those are good examples.
Huh. And what about all those wrinkles and ridges? Like what caused those?
So Those probably formed as the planet cooled
Okay.
and contracted over billions of years.
Wow. It's like an apple skin, you know, as it dries out, it gets all wrinkly.
Yeah, that's a good way to picture it.
It's a glimpse back in time, billions of years.
Exactly, yeah.
Oh, and what are those huge craters off in the distance there?
Oh, so the one you see there, that's the rim of the Mendelssohn crater.
Mendelssohn.
And then further out, that massive circular feature, that's the Caloris Basin.
The Caloris Basin, I've heard of that.
Yeah, it's huge.
How big are we talking?
It's about 1,500 kilometers in diameter.
1,500 kilometers.
Yeah, one of the largest impact craters in the whole solar system.
I can't even imagine the impact that created that.
They must have been cataclysmic.
Yeah, absolutely. All right, image number 3. Bring on the next surprise.
Okay, so this one really highlights those contrasting forces that shaped Mercury, the volcanoes and the impacts.
Okay.
So see that bright region near the top?
Oh, yeah.
That's no Theraphycula.
No Theraphycula.
And that's evidence of a huge volcanic explosion.
Like, how huge are we talking?
Huge. We're talking multiple eruptions that sent lava flowing for over 150 kilometers.
150 kilometers. Wow.
Yeah, it wasn't just one volcano, probably a whole chain of them erupting.
So, like, super volcanoes.
Yeah, you could say that.
That's mind-blowing.
And then right next to this ancient volcanic feature, you see that crater.
Yeah.
That's the Fontaine crater, and that's much younger, only about 300 million years old.
300 million? That's still pretty old.
Yeah, it is, but compared to the volcanic activity, it's relatively recent.
Wow, so you've got this ancient volcanic activity right next to a relatively young impact crater.
Yeah, it's a real contrast.
Does that mean Mercury's been getting bombarded, like, throughout its history?
Well, it certainly suggests ongoing impacts, but it also raises questions about what drives those impacts.
Yeah.
Are they random, or is there some sort of pattern?
That's a good question.
Yeah, these are the kinds of things BepiColombo will hopefully help us answer.
It's amazing how much we can learn just from these images.
Yeah, each one tells a story about these incredible forces that shaped Mercury over billions of years.
It's incredible. Absolutely incredible. I mean, those pictures are amazing. And to think those were taken while BepiColombo was still, like, hundreds of kilometers away from Mercury.
It's still a ways out.
Can you imagine what we're going to see when it's actually in orbit?
Oh, the level of detail is going to be incredible.
I can't wait.
It's already impressive what we're seeing now.
Yeah, it really is.
But when it's in orbit, oh, man.
It's going to be awesome.
And to think it can even work in that environment.
That's what I was thinking. I mean,
so extreme.
That's the closest planet to the sun.
Yeah, it's crazy.
And we talked about those temperatures. It's going from a furnace to a freezer.
It's a wild swing, for sure.
How does BepiColombo even survive that?
Well, they had to come up with some pretty ingenious solutions.
I bet.
They had to,
Like, did they give it, like, a cosmic heat shield?
Well, it's more than just a heat shield.
Okay.
It's multi-layered protection.
Okay.
They've got this special ceramic material that reflects most of the sun's radiation.
So it's like bouncing the heat right back?
Basically, yeah, keeping the instruments and electronics safe.
Smart. What about the cold, though? Like,
oh, yeah.
Those craters at the poles, those are permanently shadowed.
Right. Always cold.
Yeah. Does it have like a built-in heater or something?
Not quite a heater.
Yeah.
But the spacecraft is designed to rotate. Slowly and consistently. So it kind of distributes the heat evenly.
I see. So it doesn't get too cold in any one spot.
Yeah. It prevents any part from freezing up.
Oh, that's clever. So it's like a rotisserie chicken, keeping everything nice and warm.
Yeah, sort of like that, keeping it all at the right temperature.
Cosmic rotisserie. I love it.
Yeah, pretty cool.
So, okay, so they went through all this trouble to get this thing out to Mercury.
Yeah.
Why Mercury? What's so special about this little planet?
Well, it's a key to understanding how our solar system formed.
Oh, okay.
And how it evolved, It's the smallest and densest rocky planet.
Okay.
And its core, it's a massive iron core.
A giant metal ball whizzing around the sun.
That's one way to put it.
That is pretty cool. What's the puzzle about the core?
Well, it's unusually large.
Oh.
Compared to the other rocky planets. One theory is that Mercury might have been much bigger in the past.
Okay.
But there was this massive collision early on that kind of stripped away its outer layers.
Like a cosmic hit and run.
Yeah, leaving behind this dense iron core.
Wow. So how do we figure out if that's what actually happened?
Well, BepiColombo is gathering clues.
Okay.
by studying the surface features, the magnetic field, the internal structure.
Like a cosmic detective story?
Exactly. BepiColombo is our detective.
So every image, every little bit of data we get back, that's another clue.
Exactly, helping us piece together the history of Mercury.
And that tells us about the whole solar system, right?
Yeah, exactly. It's all connected.
That's so cool.
Yeah, and every planet we study has its own unique challenges.
Oh yeah, for sure. Like what about Venus?
Venus, that's a tough one.
Yeah, that's the one with the crazy greenhouse effect, right?
Runaway greenhouse effect, yeah.
Yeah, how do we even study Venus if we can't see through those thick clouds?
Yeah, it's a challenge. Scientists have used radar to map the surface. Radar, huh?
Yeah, penetrate those clouds.
Clever.
We even sent probes that landed on Venus, but they didn't last long.
Yeah, it's just too hot, right?
Too hot, yeah, the pressure's too intense.
Wow, so each planet needs its own special tools.
Exactly, its own strategies.
So what kind of tools does BepiColombo have for studying Mercury?
Well, one of the key instruments is the laser altimeter.
The laser altimeter, what does that do?
It measures the distance to the surface with incredible precision.
Oh, so it's like using a laser to create a 3D map of Mercury.
Exactly, super detailed 3D map.
That's really cool.
Yeah, and then the Mercury magnetospheric orbiter has a magnetometer
Okay.
to study the magnetic field.
The magnetic field, right? We were talking about that.
That's another mystery, right?
It's weaker than Earth's and it's off-center.
Yeah, it's weird.
Really weird.
And the magnetometer is designed to figure out what's going on.
So what has it found so far?
Well, early data suggests it's even more complex and dynamic than we thought.
Even more complex. Yeah, it's not simple at all.
So, more mysteries to solve.
Always more mysteries.
Oh, and there's that MIXS instrument too, right?
Oh, yeah, the Mercury Imaging X-ray Spectrometer.
That's a mouthful.
Yeah, it's like giving BepiColombo X-ray vision.
X-ray vision, that sounds pretty awesome.
It is. It analyzes the X-rays emitted when solar wind particles hit the surface.
Okay.
And that tells us what those surface materials are made of.
So it's like a cosmic fingerprint analysis.
You got it.
Wow, that's incredible. And by mapping those elements, we can learn about Mercury's geological history.
Exactly. The volcanic past, the impact events, it's all there in the X-rays.
So much information hidden in those X-rays, it's like cracking a secret code.
It really is, yeah.
So we've seen some really cool pictures, and we've talked about how tough it is to study Mercury, but what has BepiColombo actually found so far?
Well, it's still on its way there.
Right.
It won't actually be in its final orbit until 2026.
Okay.
But even now, it's sending back really interesting data.
Cool. So what kind of stuff are we learning?
One of the main things they're looking at is Mercury's magnetic field.
Ah, yeah, the magnetic field.
Remember, that weaker than Earth's and kind of off-center?
Yeah, it's a weird one.
Right. Well, the magnetometer on BepiColombo, it's been mapping the magnetic field in way more detail than ever before.
Okay, that's pretty cool.
And the findings are, well, they're intriguing.
Oh, in what way?
They're also pretty puzzling.
Oh, no. More mysteries.
It seems like the magnetic field is even more complex than we thought.
More complex, huh?
Yeah, and more dynamic.
So more questions than answers, then.
It seems that way, yeah.
What kind of questions? Like what are the scientists scratching their heads about?
Well, for example, we're seeing these variations in the magnetic field strength and direction that we didn't really expect. It suggests that there are processes happening that we don't quite understand yet.
I see. So there's still a lot to learn.
Yeah, Mercury's holding on to its secrets.
Oh, and what about the water ice?
Ah, yes, the water ice.
I mean, that's just crazy to me that there could be water ice on Mercury.
I know, right? In those permanently shadowed craters.
Yeah, how is that even possible? It's so hot.
Well, the thinking is that the water ice was delivered to Mercury billions of years ago.
Delivered by what?
By comets or asteroids that crashed into it.
Oh, like a cosmic ice delivery service?
Uh-huh, yeah, something like that.
So how do we know if that theory is actually right?
Well, BepiColombo has some really cool instruments that can analyze the makeup of those ice deposits.
Okay, what kind of instruments?
It's got a spectrometer, for instance, that can study the light reflecting off the ice.
So what does that tell us?
Well, it looks for the specific signature of water molecules.
Oh, cool. So it can confirm that it's actually water ice.
Exactly. It's like using light to fingerprint the ice.
I like that, like a fingerprint.
And the distribution of the ice. How much is there and where it is, that can tell us a lot, too.
About what?
About the history of those impacts on Mercury.
Oh, okay.
When they happened, how big they were.
So it's like looking back in time.
Yeah, using the ice as a time capsule.
That's really neat. And you were saying earlier that what we learn about Mercury can tell us things about the future of Earth.
Yeah, that's right.
How does that work?
Well, think about it. Mercury is the closest planet to the sun.
Right.
So it's constantly being bombarded by solar radiation.
Yeah, and those solar winds, right.
Yeah, exactly.
We talked about how BepiColombo needs that super-duper heat shield to survive out there.
Exactly. So by studying how Mercury's surface and atmosphere interact with a solar wind, we can learn more about how space weather affects planets.
So it's like Mercury's a test subject for understanding solar storms and stuff.
That's a good way to think about it, yeah.
And that could help us protect Earth, right?
Potentially, yeah.
So we're studying this tiny, scorching hot planet millions of kilometers away, and it could help us protect our own world.
Exactly. It's amazing how everything's connected in space.
It really is. It's so cool.
And who knows what else we'll learn as BepiColombo continues its mission.
Yeah. What else is Mercury going to teach us about Earth?
Well, it's likely to reveal even more connections, that's for sure.
I can't wait to find out. This has been an awesome deep dive.
Yeah, it has.
It's incredible to think that this little planet can teach us so much about the universe and ourselves.
It really puts things in perspective.
It does. All right, well, that about wraps up our deep dive into BepiColombo's mission to Mercury.
Thanks for joining us.
And remember, there's always more to explore out there.
Yeah, keep looking up.
Keep asking questions and keep that sense of wonder alive.
We'll catch you next time.
See you later.